Today's lecture is on object composition, and we're going to see that composition is the primary mechanism for reuse in an object-oriented programming language. We'll see that these ideas fit hand in glove with the concepts of abstraction and encapsulation that we have already seen. Now, object reuse is the ability to reuse a class or a set of classes in different contexts, and is part of the most fundamental aspects of why we would want to use an object-oriented programming language. You may recall that what an object-oriented programming language does for us is to give us the ability to write robust software, but software that is also reusable, flexible, and maintainable. So this whole notion behind reuse is fundamental to what we do, and we're going to see that composition is the primary mechanism for reuse in an object-oriented programming language. Now, in order for something to be reusable, it must first be well abstracted and well encapsulated. And that's why, as I've said to you time and time again, that abstraction and encapsulation are by far the most important concepts in an object-oriented programming language. And they are by far the most important ideas you must be able to bring into practice. So well abstracted and well encapsulated classes and components promote reuse. If they're not well abstracted or well encapsulated, they will not promote reuse. The idea here is that we don't reinvent the wheel. If we have something that is created to be robust and it's tested and it's properly abstracted and encapsulated, we can reuse it in a load of different contexts. We do not have to reinvent the wheel. And because the application has been proven, it's been tested, we can reuse it in different contexts safely. As I said already, but it's important to restate this, composition, not inheritance, not polymorphism. It is composition that is the primary mechanism for reuse in an object-oriented programming language. We'll see later that what's going to happen here is that composition will confer upon us the ability to dynamically, that is at runtime, decide the behavior of an object, whereas inheritance will allow us to do this only statically at compile time. So despite all the hoo-ha about how great inheritance is, the polymorphic behavior we get from composition is arguably more powerful than that we get through inheritance. More of that anon. A composite, okay, is something that is made up of various parts or elements. We hear about composite materials, new carbon composites, for making everything from boats and machines to fishing rods. So we talk why is composite in that context means it's composed of different elements, different kind of materials to create one super material. On another in another context, an engine, for example, is also composite. It's composed of different parts. Okay, the actual, gasket, pistons, okay, carburetor, etc. Okay, our own bodies are composed of different parts that we call organs. Classes, therefore, can be composed of different types of reusable parts. It could be fine grain or very, very coarse grain. But fundamentally, there's 4 different types of composition that we need to understand. There is the notion of delegation. That is, we're going to reuse, okay, an existing object through just delegating a method call. The second type is what's called an association. This is a very loose form of composition, that is a loose relationship between classes that exists at a method level. I should add that delegation is inside a method. Aggregation is a loose relationship between classes at a class level, and full-blown composition is a very tight relationship between classes at a class level. You should understand that all 4 forms of composition create a dependency between 2 classes. That is to say that a class that is composed with another class is dependent upon it. The most basic type of composition is called delegation, and this happens internally inside in a method. It is merely the act of forwarding a method request, an invocation or an operation, to another object to be performed on behalf of the first object. The idea here is actually in a form of encapsulation. It's declared inside a method and can only be seen inside a method. And the notion is to shield an object from the implementation changes in other objects. In other words, inside a method, I'm creating possibly an instance of another object. I'm certainly calling its method. Okay, and how that method is implemented, we will let vary in the other object. That is what encapsulation is all about. An object therefore outwardly exposes a certain behavior, and actually delegates the responsibility for implementing that behavior to some other object that it's composed with. So in other words, outwardly I say I can do the following, and when you call that method on me, inwardly all I'm really doing is dispatching, forwarding that method to another object and getting it to do it. So usually the object that forwards the request will also pass itself as an argument, i.e. you're saying to a second object, hey, I want you to do the following, and pass myself, me, or this in a language like Java, to it. Delegation is a fundamental abstraction that underpins all composition at a very, very abstract level. The primary advantage of delegation is, as I said, something that we get from all forms of composition really, and it's runtime flexibility. The delegates can easily be changed, as in all forms of composition, at runtime. This makes code far, far more reusable and lets each object worry about its own functionality, and we call this, the single responsibility principle, that each object should be doing just one thing. It also saves us spreading an object's behavior throughout an application. It's only used when it's necessary to be used, and it's only known about to the greatest extent possible internally within a method. That means that if it ever needs to be changed because it's internal to the method, i.e. it's encapsulated inside the method, it can be changed without adversely impacting any other part of the program. Delegation is best used when we want to use another class's functionality without changing the actual behavior at all. It's often a better solution than using inheritance. So the idea here is we sacrifice speed in favor of the idea of advanced clarity of abstraction. Why speed? Well, the notion that we have to actually dispatch a method incurs a cost, but that cost is actually minor in terms of running time. It's actually an O1 operation. So in implementing delegation, we often want the capability to replace the delegate with another object, possibly of a different class. That is to say, delegation can use inheritance and polymorphism. Now this is something that may seem to contradict what I said earlier, but we will flesh these ideas out as we get through the course. When I say that composition is the primary mechanism for reuse, I'm not saying it should always be done at the expense of inheritance. Rather than that, what I'm saying is inheritance it means a specific thing and should be used in a specific context. Most of the time, when we want reusability, we need to be talking about composition. However, composition and inheritance do go together in much the same way as abstraction and encapsulation go together. In other words, used together properly in the proper context, we can actually have the best of both worlds. Okay, and we'll see as we go on later, we will see that inheritance is actually a logical form of logical consequence of abstraction. Composition really arises through delegation. So it's only natural that these ideas themselves become intertwined later on. So the use of delegation through inheritance often is driven by restrictions on a programming language using threads, subclasses, or use runnable, i.e. extend thread, or implement a runnable interface. Okay, at the general level here, in delegation, the idea is that the behavior of the object that we're delegating behavior to never changes. What that means is the method signature never changes. The actual implementation may. However, if the method signature never changes, then what happens internally, i.e. as we delegate the object, does not have to change. We maintain that interface as time moves on.